Hello everyone. Today is a video on the definition of congruence and the basic properties. So you should see on your note packet this little box that I have posted on the screen here. And before I put the exercises up here, I just wanted to take a minute to talk about each one of these. The idea of congruence is that two shapes would be the same size and the same shape. That makes two things congruent. So we have a few basic properties that if shapes are congruent, they have. Alright, so if you take a look at number one here, a congruence maps a line to a line, a ray to a ray, and a segment to a segment. Alright, and what that means, this word maps, what that means is that it's like the image. Alright, like last note packet we said, well, if you start with point A and I do a reflection or a rotation or a translation on that point and it moves to A prime, well, we can say that A prime is the image of A, or we can also say that A maps to A prime. Okay, so don't let that word confuse you there. That's all that means. And when they say a line to a line, a ray to a ray, or a segment to a segment, or angle to angle, well, it's meaning just that. Alright, if I have a line segment, BC, and I do some kind of rotation or some kind of reflection or a translation or a sequence of those, and I have a line segment over here and it's B prime and C prime, well, if I say that these two are congruent, then that means there is some sequence of reflection, rotation, or translation that maps this line segment to that line segment. Alright, I could say I might rotate it and then translate it. Okay, if I switch over to red here, and I could say, well, I might rotate this line segment about point C. Okay, we'll put a little red dot there to mean I'm going to rotate about point C. I might rotate it a certain number of degrees, and it would rotate and look like that. We'll call that B double prime and C double prime. Right? And then I may do a translation which would just slide this line segment, this image that I just made, it would slide it a certain distance and it might fall right on top of this line segment here. So I can say there's a sequence of rigid motions, which would be a rotation and then a translation, that would take this original line segment to this image right here. So I could say there is a sequence of translations or rotations or reflections that map this line segment to this line segment. Okay, and if that happens, then they are congruent. They're the same size and the same shape. Alright, and that is basically what these two statements right here are saying. A congruence preserves length. So if I tell you, I'll go over here and I'll put a triangle. Alright, here's triangle DEF. Alright, and I may draw another triangle over here, and maybe it's pointing the other way here, and this is D prime, E prime, and F prime. Well, if I tell you in this little notation here, triangle DEF is congruent, see the symbol here for congruent, I've got that underlined down here, is congruent to triangle D prime, E prime, F prime. Alright, by saying this, that means that the lengths of these segments are the same. So I could say the length of DF, alright, there's my little symbol for line segment, is congruent to, and I have to match them up, DF would match up with D prime f prime. Alright, so by saying that these triangles are congruent, that tells me that these two line segments are congruent. Usually we would put little hash marks to match those up. That would also tell me that these two are congruent. Alright, these two line segments. And we'll put two hash marks saying that this line segment matches up with this line segment. And over here we can put three hash marks. That's going to tell me that these two line segments match up. And those are also congruent. So I could make a list here and I could say DE is congruent to D prime E prime, and I could also say that EF is congruent to E prime and F prime. Okay, so it tells me that the lengths of the segments are preserved, right? They're congruent, and also the degree angles are congruent. So I could go over here to my example, and I could put little arcs. Let me change colors there. I'll put this in a little. I could put little arcs. All right, this arc matches up with this arc. All right, so that would tell me that angle D is congruent to angle D prime. All right, and I could do the same thing with F. I could put two little arcs there, and that's referring to F prime. So angle F is congruent to angle F prime. All right, and of course angle E, could put three little marks there, and that would match up with three little marks there. So angle E is congruent to angle E prime. Okay, so the idea of congruence tells you a lot of things. It tells you that you have the same size, same shape, and also what we call the corresponding parts are congruent to a shape. Alright, so that would be DF, D prime, F prime. Those would be corresponding parts. Alright, down here DE and D prime, E prime. Those would be corresponding parts. Alright, so there's some basics for you. Let's try exercise 1. I'm going to turn that on. There it is. Okay, and we've got two triangles here, and they tell us that the two are congruent. So all of these things right here, they hold in these two triangles. So given the following picture, is triangle ABC congruent to triangle A prime, B prime, C prime? Well, they are definitely the same shape, and they are definitely the same size. So yes, they would be congruent. And if that is true, then there should be a sequence of rigid motions. I'm going to underline that here. Let me get my blue pen back here. I'm going to underline that right here. A sequence of rigid motions that proves they are congruent. So what they mean by that is they could be a translation, okay, or a reflection. These are all things that we've been talking about for the last couple of weeks, or a rotation. Alright, or a sequence of those. It could be one of those, or it could be a sequence of those, which we did before as well. Alright, so what I did here, and I did this ahead of time, I took this triangle and I said, well, what if I rotate it around this point right here, this B right here? And when I did, and I kind of freehand drew this in here, so what I did was I did one of these translations, reflections, or rotations. I tried one of those and I thought, can I get this to match up with this? Alright, and what I did is I decided, first I did a rotation and I couldn't see that it would match up very well. So then I tried a reflection, and let me draw just a red line in here. I imagined a line going just like this, and you could even take your ruler and draw in a line. And I said, well, what if I did a reflection over that line? And so I did that, and I got a picture like that. Alright, and actually I'm going to take this right out of there. And I got that picture so that you can see that A mapped or reflected right up here to A prime. And like we've said before, if you go perpendicular to the line. Alright, that takes you to that point. And if you go perpendicular to this red line, you take that point perpendicular, it takes you to that point. Alright, and then B, being right on the line, well, it stayed right where it was. So I did a reflection. I'll put a little arrow in here, like I did a little reflection. I did a little flip of my page. Okay, did a reflection of that triangle, and I got this triangle. Alright, and then I said, well, that looks pretty close to this one. If I just slid it, if I did like a slide that way, I could match up this right over the top of this. Alright, so my sequence of motions was a reflection, okay, and then a translation, and yeah, that proves to me that they are congruent. Okay, and really that's what they're asking us to do. Alright, what is the sequence of rigid motion? So I would say I want to do a reflection. Alright, then a translation. Okay, and that would be my answer there. Alright, now exercise 2, if I could turn that off, and I could turn that one off, okay, that clears the decks there, and turn that one on. There's exercise 2, alright? Now, this one says, given the following picture, are these two congruent to each other? So same question they have for me, and again, if they are congruent, I need to describe a translation or a reflection or a rotation that will move this original figure and map it right on top of this figure, and they want to be the same size and the same shape, or a sequence of those, right? Like two translations or a reflection and then a rotation, etc. Alright? So sometimes with these, it's almost like you have to cut out the little piece of paper and you have to try to reflect it, or you use the tracing paper, or you turn your paper and do a rotation, or etc. Alright? So a lot of thinking up in that unseen territory, up in your mind. So anyways, when I tried to do this one, I thought, well, I could reflect it, and I could rotate it, and I could slide it, but if you look at it, these are definitely not the same size. Okay, so I measured it, and I took my ruler and I measured A to C, right, and I got 4 centimeters for A to C. Now if they're congruent, A prime to C prime should be the same, and I think you can see it by just looking at it, but I measured this and I actually got 7 centimeters for A prime to C prime. So right away that tells me that they are not congruent. Alright, so you could just write that they're not congruent, or you can do this. You can say triangle A, B, C, and you do that congruent symbol, you put a slash through it, and that tells you that they are not congruent. Okay? So that's basically what we're after today, that you understand that congruence means same size, same shape. Alrighty, and if two shapes are congruent, well, there is a motion or a sequence of rigid motions, meaning these, that will map one to the other, and in this case that did not happen. Alrighty, so tomorrow's assignment will be similar to this, where we give you some shapes. Maybe those shapes will be on the coordinate plane, which makes it even easier. Then you can simply count how big the sides are and compare them and rotate them, etc. And to state that if they are congruent or not congruent and why. Alright, so hopefully that is not too difficult. And thanks for watching. We'll see you tomorrow.